Hi everyone, welcome to Geek Coding Academy. Today we'll see Collection Framework Chapter 6.6, that is comparison between list, set and map. So in our previous video we talked about on the collection framework and its core interfaces. What is list, what is set, what are Q and DQ, and what is a map interfaces. If you have not watched those videos, like you can watch into my channel. So in today's video, we'll see the overview of what are the differences between these list, set and map. So let's get started. Okay. So in Java, list, set, and map are part of collection framework. Okay. In Java collection framework, there will be two main interfaces. One is collection interface, another one is a map interface. Under this collection interface, we have a sub interfaces like list and set and map. Sorry, list, set, and Q and DQ. Under map, we have a subclasses which are implementing these map interfaces. So today we'll talk about on difference between list, set, and map. So they are all from the same collection framework and they serve distinct purpose in managing and collecting our data. Okay, managing our and collection of our data, they will provide like each set will provide their own distinct features. Okay, so we'll see the detailed comparison of these interfaces in terms of their structure, functionality, and performance characteristics. Let's see. First, we'll see what about the list interface. The list interface represent a ordered collection of elements that allow duplicates. That means like insertion order, it will preserve and duplicates also it will be allowed. It's a part of java.util.package, java.util package. Sorry, it will be present under java.util means utility, java.util package and it inherit from collection interface. Okay, it will be sub interface of this collection interface. What are the key characteristics? We'll see. Order. That means it maintains the insertion order of element, like how we insert, same way it will preserve in its collection. Okay. Duplicates, it will allow duplicates. Indexing, it support accessing element by their index because order is there. So we can access with the help of an index. Null values, it will allow multiple null values. Okay. So common implementation of this list interface are array list and linked list. What do you mean by array list? And that means like dynamic array that provides a fast random access. That is O of n. O of 1 means constant time to access by index and slow insertion or removal in the middle of the list like O of n. So in array list, there will be a fast access, but insertion operation, it's a bit slow. If you talk about linked list, it's also called as a doubly linked list, allowing efficient insertion and deletion on both ends of O of 1 for insertion and deletion at the beginning and the end, but slower access by index often. Like accessing is slow, but insertion and deletion is faster in linked list. So this is an example of list example where I have a class called list example and I have a main method. And a main method I created an array list where using an add method, I'm just adding all the values to it. Apple, banana, cherry, apple. So apple again I'm adding here, which before we have already have an apple. Still I'm adding another duplicate value, but it is allowed. In list, duplicates are allowed and insertion order is preserved. When I print this, I'll get a response like an apple, banana, cherry, and apple. When I try to get using an index, so index start with 0, 0, 1, 2, 3. When I try to get with an index 1, I'm getting a banana as an output. So the common method present in this list interface are add to add an element, get which requires an index to retrieve element at a specific index, and remove which is also remove the element at a specific index. The index of object, if you pass an object, it will return an index of first occurrence of a specified object because duplicates are allowed. So if I pass index of an apple, it will provide me a 0. Means 0th index, it will be there, first occurrence. Sublist means it's like a uh, portion of the list between the specified indexes. These are all about list. Let's come to another difference is set. So set and list, the difference between for set and list are here in set, it does not allow a duplicates and it does not maintain an insertion order. With few exception is there, like linked dash set will preserve the insertion order, but generally the set will not preserve an insertion order. It does not allow duplicates It allow only one null value at most, and it does not support access by index because the insertion order is not there. We can't able to access through index. It's also present in java.util package. Okay. So common implementation is ash set. So it uses the technique called ash table for storing elements. It offering a O of one, means constant time for basic operation like add, remove, and contains. Like assuming we have a good hashing algorithm, like we have a custom hashing algorithm we can write, but by default it will having a one hashing algorithm. Based on that, it will be um, check whether the data is available in the collection or not. Okay, that's all about hash set. We have a dedicated video for all of these guys, like in my previous videos. This is just a overview. I'm going with every interfaces. If you have a detailed video, please check into my channel. So linked asset. So I told like the one exception is there, that is linked asset. Usually set interface and its subclasses does not preserve the order of insertion, but linked asset maintain an order of insertion. Why? Because it uses a linked list concept. So provides a performance similar to an asset, but also it uses the linked list concept to preserve the order of insertion. Tree set. So wherever we see about tree set, it's all sorted by default. The whatever data we are adding, it will sort based on ascending order by default. If you want to provide any other custom orders, we can provide our own custom comparator. Then it will sort based on that. So it will provide a log n time complexity for the operation for the tree set. So let's see what is the set example. Like I've created one asset here and trying to add all the values to it. In set, duplicates are not allowed. So I'm trying to add an apple, which has already been added in previous statement, but it will ignore this. And when I print the output, it will print like apple, banana, cherry, or like similar way. So add is method used to add an element. Remove is to remove a specified element from the set. Contains, check if the set contains a specified element or not. Size returns the size of the elements in set. So let's see in other interfaces, map, which comes under another branch only, because whatever we see list and set, that will store data individually, but here in map we need to store in terms of key value base. Okay, unlike list and set, map does not extend the collection interface, but it's a part of collection framework. Okay, key characteristic, key and values. I already told when we want to store a data to it, it should be in a key value pairs. And key only one null value is allowed, and in key duplicates are not allowed, but values may be duplicate. Value there will be duplicates allowed. Order, it does not maintain a order of keys, but there is some exception like link dash map and tree map. Their order will be preserved. Means a tree map where it will definitely ordered by ascending order, and link dash map insertion order will be preserved. So null keys, only one null key is allowed and multiple null values are allowed, but the legacy classes were there, some hash table and tree map, those null were not allowed, because in tree map it will be sorted before adding, before comparing data. So it if null is present, it can't be sorted, right? So in tree map, null values are not like not allowed. And hash table also, like hash table is a legacy class where nulls were not allowed. Duplicates, keys must be unique, but values can be duplicated. Indexing, no index by position, but access by keys. So common implementation is hash map, which uses it store data in terms of key value pairs, O of one time complexity for basic operation like get and put. Linked hash map, it maintains the insertion order of key and key value pairs. It's similar to an hash map, but it will, the extra feature added here is it will preserve the insertion order. Tree map, it's actually its parent is sorted map, and immediate parent is a sorted map, and the parent of his parent will be like map interface. So based on that, like in tree map, whatever data we add, it will use the natural order of keys, means in ascending order. If you provide any custom comparator, it will take on that. Hash table, it is a synchronized thread safe, and it's a legacy class which extends this hash map that does not allow null values, even one null value in key also. So let's see a map example. This is a map example. I created an hash map. I'm trying to add another data. apple, banana, cherry, and again I need to try to add an apple here. So what it will do is it will replace the apple, which I already have. When I print it, get a values, and these values, like whatever insertion order, I can't guarantee because here in HashMap, insertion order is not preserved and duplicates are not allowed in keys. Okay. So put is a method which is used to add a data to this specified into the map. Get is to retrieve a data from the map. Remove is to remove the specified object, means which will compare with a key, and it will remove from the map. Contains key, it will check if the element is available in a map collection in hash map particularly. Like if the element is not there, if its elements there, means it's a key for that element. Whatever key we passed, if it is available, it will provide as true. Otherwise, it will provide as null. So key set, it will provide a set view of keys of the map. So all the keys it will provide in a set view. So this is the comparison list table for list, set, and map. If talk about an insertion order, list definitely list is for that. It will preserve the insertion order. Set, there is no insertion order preserved except some exception are there, like linked dash set will preserve. Map also no preservation order, but linked dash map and tree map will preserve. Means tree map here it will compare with an ascending and descending. So at least one natural order it will preserve. And linked dash map definitely will preserve the how we save our data. Except that none other will preserve a order. Duplicates list allow duplicates, it allow duplicates, but this does not allow, set will not allow duplicates. Map keys should be unique, but value can be duplicated. Null values allow any multiple values, null it will be allowed in list. Set, only one null value can be allowed at most, but here in map one null key is allowed, but multiple null values can be there. Indexing, access by index. In set, no accessing through index. And map, it's also accessed by key instead of index. Common implementation will be like for list, array list, linked list, vector, stack, etc. For a set, as set, linked as set, tree set, etc. For map, hash map, linked hash map, tree map, hash table, etc. Use cases will be when we want order, means insertion order and duplicates matter in our application, we definitely go with a list. And when we use uniqueness is important for processing our data, then we go for a set. When we want to structure our data in terms of a key value pairs, we can go with a map. So performance wise, for inside list, if you take about an array list, it's a O of 1 for operation, for getting operation. For insertion operation, it's a O of n. But for a linked list, insertion operation is a O of 1, and for get operation, O of n. For set, O of 1 for an hash set and O of log n for a tree set. For a map, O of 1 for an hash map and O of log n for a tree map. Okay. Thread safe variants, like for a list, we have that vector and copy on write array list. Those are all thread safe. They are synchronized. Set, copy on write array set is a thread safe class. And in map, we have an hash table legacy class and also a concurrent hash map. That will be thread safe. So summary for this, list is ideal for storing ordered indexed collection where duplicates are allowed. And set is perfect for storing unique elements with no duplicates, especially when order is not important. Map is the go-to choice for storing data in a key value pairs where key are unique and values can be duplicated. So each collection type has its own specific use case based on the need of ordering, uniqueness, and data access. Like understanding this distinction helps in choosing the right collection for our problem. Okay. So guys, these are about the difference between list, set, and map. And we were winding up this collection framework, having these interfaces, core interfaces, and these implementations. In our next class, we'll talk about what are the utility classes we have in this collection framework apart from these interfaces. So thank you for watching. I'll meet you guys in my next video. Till then, keep watching, keep learning. Thank you. Bye.